Hi folks, this is the solution to number 3b from the Unit 2 Lesson 8 worksheet. Okay, so this is an example of a derivative that needs logarithmic differentiation. How do I know that? Well, I see that there's a variable in both the base and the exponent of a power. Okay, so I can't find this derivative directly. I find it indirectly by working with, instead of the function itself, by working with the natural logarithm of the function. Okay, so what I'm going to do is work with the natural log of sine x to the cos x. Okay, and the reason why this is useful is because it allows me to now use the ski-slope rule and rewrite this as cos x times ln sine x. Okay, and once I have this equation down, I can take the derivative of both sides. Okay. Alright, and the derivative of the right. Okay, and what's nice about this here is on the right hand side, this is just a pretty straightforward product rule derivative. And on the left hand side, in taking this derivative using the chain rule, I'm going to produce exactly the derivative that I'm looking for. Okay, so let's do that here. So to find the derivative of the left hand side here, well, I'm going to have to use the chain rule. So my exterior function is that natural logarithm, so I'll call this thing my u. So derivative of ln u is 1 over u, which is just sine x to the cos x, and I have to multiply that by the derivative of u with respect to x. In other words, the derivative of sine x to the cos x. Okay, and that is very nice because that's exactly the derivative that I'm looking to find. Okay, so on the right hand side, just going to apply the product rule here. So derivative of the first, so derivative of cos x is negative sine x, okay, times ln of sine x, the second function, plus the first function times the derivative of the second function. So here to find this derivative, it's a composite function again, so I'm going to have to use a chain rule. Okay, so this is like my u here. So the derivative of ln u is 1 over u, so 1 over sine x. And then I have to take the derivative of this with respect to x, and the derivative of sine is equal to cos. Okay, and so now I can solve for this expression on the left hand side, because this is exactly what I was looking for all along. Okay, so that will just be multiplied to the other side, so I've got sine x to the cos x, and make sure you open up a bracket here. And so what do we have? We've got negative sine x ln sine x, okay, and plus this, we've got two coses in the numerator, so cos squared x over sine x. Okay, and there you have it. So again, just to recap, as soon as you see a variable in both the base and exponent of a power, you know that you're going to have to use logarithmic differentiation, and the way that works is to work with the natural log of that function, okay, so that you can rewrite it using the ski-slope rule, and then from there take the derivative of both sides, and what you need comes out in the